So, hi everyone, my name is Victor. This is my fourth year in FTC. I'm on team 8565 Technicbots. I do hardware and CAD on the team, and in my spare time, I like to play music, collect vinyl, and play video games. All right, so my section will be about Prusa cloud printing. All right, so just a brief roadmap for today. We're going to go over why you would want to invest some time and money into making Octoprint work for your Prusa. And then we're going to go over how to detailed step-by-step tutorial on how to actually make this thing work with supplies, Octoprint, the Unbox Funnel plugin, and Octo Everywhere. So everybody loves Prusas, right? Prusas are the preferred printer of choice for many FTC teams because they have a simple construction, they're really robust, and they can print a wide range of filaments like PETG, PLA, and TPU to suit every need that an FTC may have. However, they operate on an SD card that you manually insert into the printer with a G-code file loaded onto it in order to start a G-code print. So you have to basically be right next to the printer when you want to start a file. So just something that happened last season, especially during the early stage of our season and in the rushes to prepare for higher levels of competitions like states and worlds, we would have printers doing a lot of CAD and submitting 3D printed parts in the 3D printing queue. And the queue would run overnight, and sometimes it would be due the next night or the afternoon of the day after the next day for prototyping and building. And since I didn't want to overbatch out of fear for making the print fail, I would split all the parts into multiple batches, running from the evening into overnight into the morning. And after that, I can't print during the school day, which would waste me up to 8 hours in a single day not being able to print parts. And then immediately rushing home after school to desperately start the next batch and see if it can make the deadline in time, which usually results in parts getting delayed. And what's even worse is you can't print emergency parts very manually. You can't print if you're away from home, and your printer is basically useless if you're out of town. So this is something that obviously we want to optimize with our 3D printer. And this is where Octoprint comes in. So let's talk about supplies. So this is a picture of my old setup. All of the components, all the key components are pretty much the same. In the corner over there, taped to the table leg, is a Raspberry Pi 4 in a cooling enclosure. And you will want to have a cooling enclosure because you're going to be running your Raspberry Pi 24/7. It's connected to the printer with a blue firmware cable that's plugged into the firmware update port. And then you have a Raspberry Pi USB-C power supply that's plugged into a power strip, a lamp, and finally a webcam which is mounted on the chair behind the web camera or behind the lamp. So let's talk about setting up Octopi. So when you set up your Raspberry Pi, the most important thing you want to do is find your Raspberry Pi's IP address. You can do this by connecting your Raspberry Pi into your own computer or your laptop with Ethernet cable. You're running some command lines, or you can plug it into a monitor and pull up the command line from the Raspberry Pi's desktop and type in the command hostname-i. And from that, you can get your Raspberry Pi's unique IP address. There are multiple ways you can find on the internet to do this. This is just one of the easier ways. Next, you want to download the Raspberry Pi Imager by Googling Raspberry Pi Imager and installing the software. Now, once you pull it up, we're going to actually find the Octopi software to write into a Raspberry Pi. So we're going to go into operating system, other specific purpose OS, into 3D printing, Octopi, and Octopi Stable. And you want to find a micro SD card, plug it into your computer, and flash the Octopi Stable software onto your SD card. And then you want to go into your Prusa 3D printer and check the R5 port and settings to be on. And then you want to insert the SD card into the Raspberry Pi, set the Raspberry Pi up, plug it into the firmware port with your firmware cable. And with that, you can go to this link right here, http://octopi.local. And now I'm going to run through a brief Octoprint UI walkthrough as a live demo. So hang on one second. So as you can see here, this is the Octoprint UI that you will see when you load into Octoprint. So in the upper left-hand corner, you'll have your connection and your state statuses. These you typically don't want to touch at all. It'll just show you the status of your 3D printer when it's connected and some details about the G-code file that you have in your queue, like the upload time, the time-lapse configuration, and some of the progress status. And then you'll see on your right-hand side of the screen, you'll have 5 sections, starting with temperature. So in the temperature, you'll see a temperature graph in which you'll find 2 lines for the temperature of your bed and temperature of your nozzle, and you can manually set the temperature of both tools with a tab down here that's been blocked for some reason. But once you set temperatures or print starts, you'll see the lines start moving, and that will show you the temperatures of your tools. The next tab over, you'll have your control tab, and this is where you'll find all your manual axis moving tools, as well as the webcam stream. Next, we have a G-code viewer, and when you load in a queued G-code file, you prepare to print it. This G-code viewer terminal is where you will be able to see a visualization of the G-code that you put in. And as a bonus, when you're running the G-code file and it's actively printing, you'll be able to see live the exact tool path and layering of each layer through the G-code viewer. Next, we have a terminal. You usually don't need to pay a lot of attention to this. This is just a constant log between commands sent between your computer and your printer.
Sorry, because we have like it's almost 5, and we're about to lose everyone that's helping volunteer, and also the custodian. So they need to clean up too, but they're leaving at 5, which is like in 9 minutes. So we need to like walk through and make sure there's no trash left, like water bottles and stuff. So we can just chill. Okay. All right. Thanks.
Okay, and then we have the time configuration. Okay, so that's all pretty sweet. And that's pretty sweet, I would say, but everything we've done so far will only work if your computer and your Raspberry Pi are connected to the same Wi-Fi address. If you go to a different Wi-Fi, it will not work, which defeats the whole purpose of why we want to do this project. This is where the Ungrok Tunnel plugin comes in. So with Ungrok Tunnel, you basically create a private remote access tunnel with encryption and auth tokens in place that will connect the IP address and local and private network of your Raspberry Pi to your computer from whatever internet you wanted to.
Guys, we need to wrap it up.
Okay.
Yeah.
Like,
Right now.
yeah.
Okay, I guess I'll skip all this and just show you a quick demo of Octoprint with Ungrok Tunnel plugged in. So just to prove that, like, I won't be able to print anything for you, which was originally my plan, but just to show you that this is indeed live, if I go click this right here, that move. If I click a Z up, you can see the Z axis moving. So this is proving that this footage is indeed live and I am controlling the printer remotely. All right, I guess I have to stop there because we're wrapping up in-person sessions. We have to clean out everything. So thank you.
No, that's online. You can have it later.
Thank you.
Is there like a tutorial for this somewhere?
Oh, you can find it online.
Oh,
yeah.
So what should I search? Just like just
Octoprint with Prusa and Mark III S+.
And do you have to set up like get a dedicated camera for this?
Any web camera would work.
Oh, okay, thank you.
You're welcome. All right, question online. Which specific Prusa 3D printer model are you using? So I'm using a Prusa i3 Mark III S+. And with FTC, the filaments we plan to use are just PLA, PETG, and TPU. Yeah, and that's all I have time for, I'm pretty sure.